Good morning to everyone. I'm Dr. Sumemas. The topic of my today's presentation is non-ideal IV characteristics from Unit 1 MOS transistor principles. On completion, the students will be able to describe the non-ideal IV characteristics of a MOS transistor. Non-ideal IV characteristics. Most characteristics degrade with temperature. It is useful to have a qualitative understanding of the non-ideal effects to predict their impact on circuit behavior. Mobility degradation and velocity saturation. Current is considered to be proportional to the lateral electric field between the source and drain, and a high voltage at the gate of the transistor will be attracting the carriers towards the edge of the channel, thereby causing some carrier collision with the oxide interface layer, and as a result there will be a slowdown in the mobility of the carriers, and this is said to be as mobility degradation. Carriers approach a maximum velocity when high fields are being applied, and this phenomenon is termed to be as velocity saturation. Channel length modulation. The PN junction between the drain and the body forms a depletion region with a width LD that will increase with the body voltage, and the depletion region effectively shortens the channel length from L to L effective, where L effective is equal to L minus width LD. To avoid the body voltage into the calculations, let us assume the source voltage to be close to the body voltage, that is VDB is equivalent to VDS. Hence, increasing the source voltage VDS decreases the effective channel length, and a shorter channel length will result in a higher current. Thereby, the current increase in current will increases with increase in the source voltage, and this results in saturation. Threshold voltage effects. Threshold voltage increases with the source voltage, and this thereby decreases with the body voltage and decreases with the drain voltage, along with an increase in the channel length. Body effect. When a voltage, source body voltage is being applied between the source and the body, it increases the amount of charge required to invert the channel. Hence, there is an increase in the threshold voltage. The threshold voltage is given by the following equation, and here Vt0 is the threshold voltage when the source is at the body potential, and pi s is the surface potential at the threshold, and gamma is the body effect coefficient. Leakage. Even when transistors are in off state, there will be some small amount of current which is considered to be as the leakage current. The leakage mechanisms include subthreshold conduction between the source and drain, and the gate leakage from the gate to body, and junction leakage from the source to body and drain to body. So generally we consider the leakage to be a subthreshold leakage or gate leakage as well as junction leakage. Subthreshold conduction is caused by the thermal emission of carriers over the potential barrier that is set by the threshold. And gate leakage is a quantum mechanical effect caused by tunneling through the extremely thin gate dielectrode. Junction leakage is caused by the current through the PN junction between the source, drain, diffusions and the body. For an ideal transistor, as per Shockley long channel transistor models, the drain current, the drain source current can be given as the following for cutoff region, linear region as well as saturation region. Quiz questions on non-ideal IV characteristics. List the different non-ideal IV characteristics. Write down the different leakage currents in the MOS transistors. Thank you.